Right, implementing and verifying EIGRP. Now there are two ways in implementing EIGRP. Even the verification, there are two ways. One is mentioned in this presentation, which is a traditional way, a classical way. There is also a new way of implementing, configuring and verifying EIGRP. So I'll be doing a lab on EIGRP, both the classical way and the new way. Side by side, we'll have two different routers running same EIGRP autonomous system number, let's say 100, but the implementation method will not use the same method. On one router we'll use the classical way, the other router will use the newer way. Now this one which you are going to see, this one is a classical way, where we say router EIGRP and a number. This number will be any number between 1265535, because 16-bit is dedicated for this purpose, autonomous system number identification, 16-bit. All those routers that have got same autonomous system number, they form neighbor. In the previous class I showed you, in the hello packet I captured and I showed you, I remember. It was sending the AS number as well as the K values. Do you remember that? Did I show you?
Yes, I remember that in Wireshark.
Yes, exactly. Now, the autonomous system number must match with the neighbor. Also the K values should match. If one router focuses only on bandwidth, which is K1, and all the rest are 0, in another router this focuses both on K1 and K3, which is bandwidth and delay, they cannot form neighbor. Even they belong to autonomous system same 1000. Even though the autonomous system number is same, because the K values are mismatching, they can't form neighbor. It's very important for neighborship. In the hello packet, the K values should not mismatch. I'll do this exercise and show you. I'll mismatch and show you what problem we face. By default, the K values will not mismatch. Why? By default on all routers, K1 and K3 is considered for metric calculation. K1 and K3 is 1 by default. So there is no problem if you leave it default, but only when someone go and change it, problem starts. When I go and make this K3 as 0, then the neighborship will break. Or if the neighborship is not yet established, if I try to establish, it won't establish because of the K value mismatch. Fine. Now, in order to advertise the network, we use the network command, and then the network. If it is not class full, then we use a wildcard mask to match. In wildcard mask, if I have 255, which means you don't care. If I have 0, then you need to match exactly. For example, when I have a router with 10.1.1.0/24, 10.1.2.0/24, If you wish to run EIGRP only on this interface, only on this link, let's say this link name is E0, you don't want to run here, only on this you want to run EIGRP. So what I can do is, it's very easy. I can go and say network 10.1.2.0 0.0.0.255 as a wildcard mask. What does this mean? The first octet, second octet and the third octet should be this on the interface. So this is the only interface that has got the 3 octets matching. The last octet can be any number, that's why 255. It can be 1, 2, 3, 4, that doesn't matter. So EIGRP is going to run only on Ethernet 0 because the wildcard mask helps you to filter easily. This filtering, see, I have filtered this route from running EIGRP. This interface from running EIGRP. Ethernet 1 is no more in EIGRP because of the wildcard mask. It is not that easy to do this in other protocol like RIP. In RIP, you don't have a concept of wildcard mask. But in EIGRP, you can easily filter. Now, EIGRP considers bandwidth and delay. And if you wish to give a customized bandwidth, the bandwidth on the link may be 1 gig. But bandwidth on the link is 1 gig, but the service provider has provided you only, let's say, 500 meg, just for example, 500 meg. That's what you are allowed to consume. That's the amount of bandwidth that you can consume. The link capacity is 1 gig, but allowed is only 500 meg. So we can go and tell EIGRP that I got only 500 meg. You need to convert in kilobits and tell. Otherwise, EIGRP will think that you have 1 gig, means 1000 meg. EIGRP will think that you have 1000 meg as a bandwidth. So this is the reason why we need this command bandwidth. If you want to have a customized bandwidth, we use this command. We go under the interface, we put this command and we say how much interface EIGRP needs to consider on this port. Likewise, you can also set delay value. Delay and bandwidth are constant, whereas load, reliability, they are variables. When there is a heavy traffic, load will be high, reliability will go down. When the traffic is less, reliability will be more and load is less. So EIGRP don't consider that load, that reliability, because they keep changing time to time. When the traffic goes high, the reliability goes down. When the traffic is less, reliability goes high. So you cannot keep on shuffling between the paths by trusting those variables. By default, EIGRP algorithm is designed to consider only those constants, the bandwidth and delay. So you can set the bandwidth value as per your wish by going under this interface. Even the delay, the command is delay. Go under the same interface and say delay. Now this is not something difficult part for you. Here what they are saying is router A has got 10.1, 10.4, 172.16.7, 170. So you can just run all the 10 networks of this router, all the 172.16 networks of this router. When you say this, all these 4 interfaces now will be running EIGRP. This 10.000 will run EIGRP on serial 0 and Ethernet 0. This 172.16 will run on serial 1 and serial 2. What we should not do is, we should not say network 192, because network 192 is nowhere in any of this interface. 192 belongs to router B. You can put there, but not in router A, because 192 is not in router A. Praise the Lord. Next, usage of wildcard mask. As I already told you, if you want to filter, see, I do not want to run EIGRP in this link. I do not want to run. So 172.16.5 I have not included. I said if 172.16.3, the first 3 update. If it is 3 and 4, you run EIGRP, which means EIGRP runs on this and on this, not on this. That's why we need wildcard mask. We filter this. We do not want EIGRP to run on this. If I don't mention wildcard mask, it will consider 172.16.00, which means it will start running on all 3 interfaces. Wildcard mask helps to filter interfaces from running EIGRP. Now this command helps to inject a default route. In OSPF, you might have seen in production in OSPF, they use a command called default information originate. The default information originate command in OSPF generates LSA type 5 default route, means external default route, so that every router will use that to go to the internet. Every router inside the organization which runs OSPF can use it. When we go OSPF, I'll make it clear for you. Now, even in EIGRP we have similar concept. But not every iOS will support. Some iOS have got some problem in this. So what I'll do is, I will provide you my early batch video where I have demonstrated this. Because sometime after spending many minutes of doing this lab, I have encountered that there is a problem in the iOS. So not all iOS will support this. Now what is the purpose of this? The purpose of this is to make EIGRP to distribute the default route info. You see? D star. Usually EIGRP routes are D. Then what is the star? Default route. This is a default network which is appearing in router B, given by EIGRP. Why it gives like that? Because in router A we have a default network defined for 170.31, and that 170.31 there is also a static route to reach, and that network is also advertised in EIGRP. That's the key. We have defined a network, the ISP's network, as a default route, default network. We have a static route for that ISP, and we have advertised that default route under EIGRP. So EIGRP says this network that I am advertising from router A is a static default route. Because it is a default static route, for us it will be default EIGRP route, D star. So now, what is the advantage of default route? If any destination RB wants to go, it will send to RA. RA will send it to ISP. Simple. If you go and ping some network 88.88.1.1, there is no route for 88, but RB knows that this is the default network where I need to forward this. All unknown destinations can be routed from there. So it will be forwarded to this address, to this router 2, and router means 0.2 is router 2, means router A, Router A receives the route, and using the static route it pushes the packet to ISP, and ISP knows where is 88. So instead of we manually writing default route on every router, we know what is default route, right? Any network, go there. That's what default route. Instead of writing manually on every router default route, we define a network, ISP's network, as a default network on the edge router. Here in our case, in our topology, router A is the edge router, and the default network is advertised in EIGRP, so that EIGRP can advertise it to the internal routers as a default network, using which all the internal routers will reach ISP for unknown destinations. Do you understand this?
Yeah.
Alright, then the demo for this is, for this topic, the demo for this topic, I'll share a video after this class. Kindly go through this demo video where I demonstrate this. Let's move on to the next topic. So this is a simple configuration. You can configure EIGRP. See, this tool needs to run EIGRP. On R1 we have 192.168.1/27, which means 3 bits are borrowed from here, the 4th octet. See, 224. 3 bits are borrowed. Manually bandwidth is set, and this is /24. This is also not a classful. So here we are using wildcard mask to say 24 bits should match, means this 3 will match. Here we are not mentioning anything, so it will just run EIGRP if the first 3 octets are 192.168.1. And this belongs to autonomous system 100. So router 2 also should belong to, this is router 2 configuration. Done. Next, some verification commands. See, show IP EIGRP neighbor. This is a classical way of verifying. I told you we can configure EIGRP in 2 ways. The classical way, which we are discussing now. The new way, the modern implementation way, I'll be doing in our demo. Even the verification command, you have a modern way, modern command to verify. In our new EIGRP verification command, same output will come, but the show command will be different. See, every router will support both a modern way and the classical way. I'll do and show you. So what I'll do, in the older way it is show IP EIGRP neighbor. In the new way, in the modern way, we say show EIGRP, address family, IPv4 neighbor. This big lengthy command you have to type in the newer verification method. Same output will come, but we don't use the IP, instead we use IPv4 and IPv6. The command remains the same for IPv4 and IPv6, only this will change. I'll show you the advantage of using the newer method when we go there in the command line. Now, I've shown you 2 ways of verifying the same output, checking the neighbor. Show IP route, EIGRP will show only the EIGRP learned route. Simply typing show IP route will show the connected as well as EIGRP learned routes. But when you type EIGRP after the command route, then it will show only the EIGRP routes. D means dual. show IP protocol command will show all the routing protocols that are running on a router. Currently we see EIGRP alone with autonomous system 100 running, and you see the K values. I said K1 and K3 will be considered on, all the rest are 0. This must match with every neighbor. The autonomous system number also should match with every neighbor. And then by default, the maximum path for load sharing, if paths are available, maximum paths that will be used for load sharing is 4 by default, but I said you can tune up to 32. And on router 1, EIGRP is running on these two network enabled interfaces, and this is the neighbor's address. Administrative distance is 90. If you will learn an external network, meaning redistributed network into EIGRP, then administrative distance will be 170. So what is the administrative distance of EIGRP? It is 90 for internal, for EIGRP's own network. For the redistributed network, for the network that is coming from some other source into EIGRP, administrative distance will be 170. Now this is another command to verify all the interface that runs EIGRP. Show IP EIGRP interfaces. Listen, we have something called passive interface. If I put an interface as a passive interface, that will not be listed in here, because the passive interface won't be sending any update out, not even a hello packet. So all those passive interfaces configured under EIGRP, passive interfaces, will not be listed when you type this command, show IP EIGRP interface. As I said, for every classical command there is also newer command. Same, show EIGRP address family IPv4 interfaces. Same output you will see.
That's the old one, the show address IP family IPv4. That's the old one, correct?
This is old way. The address family command is a new way.
Ah, the long way. Okay, understand.
Yeah, the long way is the new way, and this is the old way, classical way. Now, show IP EIGRP topology will show all the destinations learned through EIGRP updates, and for each destination you will have one or more paths depending on the topology, with the feasible distance and the advertised distance. Show IP EIGRP traffic command will show how many hello packets are sent and received, how many updates are sent and received, query sent, received, reply sent, received, acknowledgement sent and received, and so on. These are all dynamically generated numbers. Yes, question please.
Can you go back one slide?
Yeah, here.
Okay, so you said that, so is it that if a interface is up and running, is in a passive state, and from what I understand, and if there's a topology change or an interface goes down, then the topology or interfaces they change over to active in order to establish the feasible distance to success it. Am I understanding that correctly?
Yeah, partially right. You see, active means it is still under the process of maybe calculating the metric, or in the process of deciding whether to choose this or that. It is still under process. It is not finished picking the best path. That is the meaning of A, active. Active means it has not finalized the path to the destination. P means path is already finalized, determined. P is good.
Okay, understand.
Right. So in this chapter, it was a small chapter, we learned about implementing and verifying EIGRP. But we learned only the classical way. Let us also now learn a new way of doing same what we have learned. But I'll do that on the command line. So this is what the topology for understanding two things. One is the two different way of implementing EIGRP, configuring EIGRP. The second one is the summarization. You know, the older version of EIGRP used to do auto summarization, but the newer version will not. We have to do it manually. If you want to enable auto summarization, you can simply put auto summary. In the older versions, we used to say no auto summary to get a detailed routes. Usually they summarize by default, but here the newer version of EIGRP will not summarize. Newer version of EIGRP will not do auto summarization. Won't do auto summarization. So those things we are going to see, and then we are going to see some verification commands, some debug commands, and so on. Yep. So here we go. Router 1. Interface loopback 0. If you notice that I have taken a subnet of 192.168.1. 192.168.1.0 is the network, .1 is the first IP of this mask 255.252.5.224. 3 bits borrowed from the host bit. Next. Interface loopback 1. This is going to be 32 is the next network, 33 is the first IP. If I don't put this mask correctly, then this will throw error saying you are adding a duplicate network. Here it's not showing error because the mask is correct. Okay, so we got the loopback interfaces. All 3 octets in these 3 interfaces are same, 192.168.1. Only the 4th octet is different. Next, the interface, the physical interface name is G3/0, means G is Gig Ethernet 3 is slot 3 0th port, slot 3 0th port. So interface G3/0, I put the IP address 10.1.0.1.245.2.5.0.0. Show IP interface brief. So we can see here Gig Ethernet having the IP address and the loopback having these IP addresses. Next, moving on to router 2. Interface loopback 0. I just want to have a network called 2.2.2.2. Just for testing, I am adding a loopback interface, which I have not mentioned in this workspace. I'll put this here, 2.2.2/32. This is on the loopback 0. So router 2 loopback 0 has got this. Now interface G3/0 10.1.0.2 finished. Now the basic configurations are over. Now we are going to get into the main part. Before that, let me verify whether I am able to ping the adjacent router. this ping should happen, but I will not be able to ping the loopbacks because I don't have the route for reaching the loopbacks of R1. Likewise, I don't have a route for reaching the loopbacks of R2. Show IP route. There is no route for 2.2.2.2 network, which is loopback of R2. Now, what is next? I'm going to run EIGRP the classical way, the traditional way on R2 in router 2. So let me start from router 2. Router 2, let's say the autonomous system number for us is 1000. So I'll say router EIGRP 1000 network 2.0.0.0 network 10.1.0.2. This is also possible. I can say if only this 4-octet matches an interface, EIGRP should be running on that interface. Now, please focus, please note this one. When I type do show IP EIGRP interface brief, so not brief, interface, you can see both the loopback and gig runs EIGRP. But when I put this command, passive interface default, what does that mean? All the interfaces are passive. Now if I go and type this command show IP EIGRP interface, no interface will be shown. Listen, even though those are under EIGRP, because they are passive interface, they are not listed here. So what I want to do is I just want to have only loopback as passive. See, when I make loopback as passive, it doesn't mean that loopback network will not be advertised. It will be advertised, but it will be advertised, but no hello packets will go on the passive interface. That network will be advertised. I'll show you in some time. Now what I want to do is, I said passive interface default, so all interfaces are passive now. That's why I don't see any interface in the output. No interface is a member of EIGRP. I'm going to say no passive interface only for G3/0. I'm cancelling that. Now if I put that same command, I'll see only G3/0. You see, the loopback is no more. Loopback is still not reflecting here because loopback is still a default passive interface. When you say passive interface default, it is applied. The passive interface command is applied to every interface. Alright, now router 2 is ready, finished configuring. I finished configuring and I use the classical method. See, show run section router EIGRP. This is what I configured. I've used the classical method. Now I'm going to go to R1 to configure the new method. Are you ready for the new method?
Yes.
Let's go. In R1, I'm going to say router EIGRP. I'm going to give a name. The name is Ted. Just a name. What is the difference between using a name instead of an autonomous system number? When you use a name like this EIGRP can be used for both IPv4 and IPv6. But when you do like a classical way, the older method, this is only for IPv4. If you want for IPv6, you need to do like this: IPv6 IPv6 router EIGRP 1000. This is two separate EIGRP you have to enable. Two separate EIGRP. IPv6 unicast routing. It's two separate EIGRP. This EIGRP is different from, this is IPv6 EIGRP, and this one is IPv4 EIGRP. See, even the mode is different. This is RTR mode, this is router mode. In classical method, you need to do separately for IPv4 and IPv6, whereas in the newer way, this is common for both IPv4 and IPv6. Now we need to go inside and say address family IPv4 autonomous system 1000. Likewise, you can say address family IPv6 autonomous system 1000. So under single EIGRP process, you may have more than one address families, one for IPv4, another for IPv6. This is one big advantage of this newer way. Next, we have a command called AF interface, address family interface. And when I say address family interface, default means I'm now right now under all the interfaces that is going to be part of EIGRP. Currently I am inside all the interfaces that is a part of this address family, that is a part of this EIGRP IPv4 1000, and I can simply say passive. See the difference in configuring passive interface there and here, it is different. And now I will go under the physical interface, AF interface gig 3/0, no passive interface. This puts all the interfaces passive, and I have excluded only this from being passive, physical interface. Next, to advertise, it's the same network command 192.168.1.0, and another network is 10.1.0.1 0.0.0.0. Now see, you got a new adjacency. EIGRP is ready, but I also told you the summarization is not by default. Sorry, the summarization, it's not by default. So if you go to router 2 and check the routing table, show IP route EIGRP, you got the detailed route, which means they have not summarized. They're not summarized. The default summarization is off. In the earlier version, default summarization was on. See, show IP protocol, that summarization is disabled. In R1 it is disabled. In R2 also it is disabled. Show IP protocol. It is disabled. That's why it is sending a detailed route without summarizing. Now I am going to enable summarization so that router 2 will have just a single route instead of this 3 route. How can we do that? Let's see. Router EIGRP TED address family IPv4 autonomous system 1000. There is a command called topology base and say auto summary. So now I enabled summarization. Only the summary route will be advertised to the topology. That's why I went under the topology base to configure this. See, this is the way to configure the newer EIGRP. Now when I go to router 2, I should see now, before that I want to check whether it is enabled. Show IP protocol. Last time it was showing disabled, but now it says it is enabled. On 3/0 it is sending a summary route. This 3 is summarized and sent on G3/0. Now let us go and verify that on R2. Earlier we were having 3 specific routes, but now a resync has happened with the neighbor. Let's go and check. Look at this, we got only one route. But I can still ping 192.168.1.33. So that's about the summarization. That is about configuring EIGRP using the new method which we did in R1 and traditional method which we did in R2. And I said there are some show commands. The older way of verifying topology is show IP EIGRP topology. This is how we used to type. Show IP EIGRP topology. But the newer method is this. Show EIGRP address family IPv4 topology. You see, same output. Let me show you both. You see, it's the same output. Recommended is this. Why, you know? The command will be varying just here if you are having IPv6. Just only there it will be 6 instead of 4. There will be some consistency in the show command if you use this one. Whereas the old one command will be varying a lot. Next, if you want to refresh the neighbor, we use the command like this. Clear EIGRP address family IPv4 neighbor who is connected on gig ethernet 3/0. See, it got cleared, it get resetted manually and adjacency has come back again. It went down manually and it is resetted. If you want to refresh EIGRP, you may use this command clear EIGRP address family IPv4 neighbor and the interface via which the neighbor is connected. Now, do you remember, if a route is not satisfying the feasibility condition, it won't be seen in the topology table. If you wish to see even those paths that is not in topology table, we need to put this command topology all links. But right now we don't see that because we don't have any path as a backup path in our topology. We have just only one path. If you will have a backup path, and if the backup path didn't satisfy the feasibility condition, it won't be shown in the database, it won't be shown in the topology table. But if you wish to see, you can put this all links so that all links will be shown. The primary, the backup, and even those links that didn't qualify to be a backup. When I do unequal cost load balancing, I'll use this command again and I'll show you the difference. If you want to debug EIGRP packet, this is the command. Debug EIGRP packet ters. So you will start seeing the other packet. So let me refresh EIGRP by clearing. Now you will start seeing, see, a lot of EIGRP packet will come. Look at this. All these debugs. It is sending update packet, update acknowledgement, you know. Then if you go top, you can see updates in it. It's initiating the neighbor, right? So debug can also be used for troubleshooting. If you don't have Wireshark, you may use debug to troubleshoot. Fine. So kindly go through this video. I'll upload this video and send you the link like as I did in the previous class. Go through the link if possible. Try to do this lab. Before I close, I want to show you an output on R1. R1 we use the newer method in configuring EIGRP. So let me show you how it looks in the running configuration. Show run section router EIGRP. You see, programmatic, like programmable approach. Yeah, but it's not difficult. See, it's easy. All right. Oh, fine then. Any question?
Nope. I'm definitely going to review the video and give it a try myself.
Wonderful. Happy to hear that. See you tomorrow, same time. Thank you so much. God be with you. Good night.
Mm-hmm.